In this lecture, we are going to see sample paper 2, and there are physics, chemistry, as well as bio questions. We are going to see only physics and chemistry. I am not going to explain bio. Okay, first question in section A, 2 marks question. First one, if you see, study the table and answer the following questions they are giving. And they are asking like, okay, there are two atoms, atom A and atom B. Atom A atomic number is 11, atom B atomic number is 17. And two questions are there. Compare the positions of A and B in the periodic table. So they are asking, what about the position of the atom A and atom B placement? Second one, which type of bond is formed between A and B? Okay, first let us try to analyze. Atomic number 11 in the sense that is sodium. Atomic number 17 means that is chlorine. Now we are coming to periodic table. Now if you observe, this is the outline of periodic table. Here we have hydrogen, then here it is helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, right, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Now if you observe numbers, this is the first group, second group, 3, 4, 5, 6, 7, 8. So like that will be going on 18th, 17th, 16th, 15th, 14th, 13th. So here it is from 3 to 12. Now they are asking about sodium. If you observe this sodium belongs to first group and period number 1, 2, 3. First group and third period. While coming to chlorine, chlorine belongs to 17th group. Chlorine belongs to 17th group, and while coming to the period, it belongs to third period only. So both elements are staying in third period, but while coming to sodium, it is first group element. While coming to chlorine, it is 17th group element. That is the answer you have to write. Which type of bond is formed between A and B? Okay, if you observe that A, which is sodium is metal, and while coming to B, that B element is chlorine, which is non-metal. Always metal will be losing electron, that electron will be transferred to chlorine. So sodium's one electron will be transferred to chlorine. So transfer of electrons nothing but ionic bond. So answer is ionic bond you have to write for the second one. Such that A plus B gives rise to AB. If you want, you can write this one also, but ionic bond is the heart of the answer. Like that you are going to get 1 and 1. Next, second question. Using part of periodic table shown below, arrange each of the following series in order of increasing size. Okay. A question they are asking like lithium, B2 plus and B. Now we have to arrange according to increasing order of sizes. Okay, increasing size. Now you see, if you observe periodic table, let me erase this and you will get some clarity. Okay, they are talking about lithium, beryllium and Be2 plus. Now lithium atomic number is 3, beryllium atomic number is 4, and we have discussed trends in modern periodic table. If you are moving from left to right, while coming to atomic size, that atomic size will decrease. Why atomic size will decrease means, if you are moving from left to right, of course atomic number is increasing. While atomic number is increasing, automatically proton count also increases. Atomic number 1 means 1 proton, atomic number 2 means 2 protons, atomic number 5 means 5 protons, atomic number 10 protons. When proton count is increasing, automatically not only proton, neutron count also will increase. In nucleus, if proton and neutron counts are increasing, nuclear charge will increase on the electron, such that, consider this is nucleus and these are orbits. When number of protons and neutrons are increasing, nuclear charge will increase. Because of the nuclear charge, this nucleus will attract all the electrons towards the nucleus. Because of the attraction, that orbit will shrink. Orbit shrinks because of nuclear charge. Now you see, lithium, if you consider lithium is atomic number 3 with a big atomic size because of 3 protons. While coming to beryllium, because of 4 protons, its size somewhat decreases like this. You see, this is lithium, this is beryllium, size is decreased. And again they are asking about Be2 plus. What is the meaning of Be2 plus? You see, beryllium atomic number is 4, meaning is 4 electrons, 4 protons and 4 neutrons. Anyhow, neutral charge, leave it. 4 electrons, 4 protons means basically atom is neutral. Now they are talking about Be2 plus. 2 plus in the sense positive charges are increasing. two positive charges increased. Basically, we cannot increase positive charge. Na? We can remove 2 electrons. So simply to say, if you remove 2 electrons from 4 electrons, at last there will be 2 electrons, but proton count is not changing. It is 4 plus only, 4 protons. Now the value will be -2 plus 4, which is nothing but plus 2. So simply to say, Be2 plus beryllium ion is losing 2 electrons. Now you see, when it is losing 2 electron, proton count is 4, electron count is 2. There will be more nuclear charge. Because of the more nuclear charge, still its size will decrease because of attraction. Now lithium size, if you compare this one, beryllium size is this one, Be2 plus size will be smaller than Be. Beryllium ion will be smaller than beryllium atom. Now we have to write increasing order of atomic sizes. So which one will be very small? This one, which is Be2 plus. So Be2 plus is smaller, less than Be, which is less than Li. This is the answer you have to write. Now same thing you can apply for chlorine, sulfur, sulfur ion. Now okay, same thing. Once again, I'll repeat the concept. If you didn't get it, once you listen. Chlorine, sulfur, sulfur ion. Now, chlorine atomic number is 17. Sulfur, sulfur, chlorine, argon. So, sulfur atomic number is 16. Now, sulfur 2 minus they are talking. We'll discuss about this. Now, you see, chlorine 17 means it has 17 electrons and 17 protons. Now, sulfur 16 atomic number means 16 electrons and 16 protons. Now what I said, if you are moving from left to right, when atomic size increases, when atomic number is increasing, proton count also will increase. When proton neutron counts are increasing, nuclear charge will increase. When nuclear charges are increasing, when attraction force is increasing, that orbit will shrink because of more charge. Now you see, chlorine's atomic number is 17 and sulfur's atomic number is 16. 16 means 16 proton, attraction is less. 17 means 17 proton, attraction will be more. Now sulfur atom size, if you consider this is the size of the sulfur, chlorine size will be somewhat small than sulfur, right? Okay. Next, S2 minus they are talking. S2 minus means negative charges are increasing, means 16 electrons, 16 protons. They are talking about 2 minus. 2 minus means extra 2 electrons are added. Now 18 electrons. When 18 electrons are given, there are only 16 protons and number of electrons are increased. 18 electrons, there will be no attraction. So this size will be big. So sulfur ion size is bigger than sulfur. Now what we have to represent? We have to write the order, increasing order. Now which one is small? Chlorine is small. So chlorine is smaller than, next size is sulfur. Sulfur, which is smaller than sulfur ion, which is 2 minus. Like that you have to write the answer. So this is the answer for that. Now second one, write the name and symbol of all elements that occupy the same row of the periodic table as nitrogen. Fine. They have given hint, this is nitrogen, and we have to represent all the atoms which are present in the same row. What they are asking? Name and symbol. Boron B, carbon C, nitrogen N, oxygen O, fluorine F, neon Ne. That's it. 1, 2, 3, 4, 5, 6. 6 elements you have to write names and symbols. So boron, carbon, nitrogen, oxygen, fluorine, neon. That's it. Then third question, bio, fourth bio, fifth bio. Okay, sixth one, physics. A student has 2 copper coils wound on a single non-conducting cylinder. Okay, this is a plastic. He connected one coil to the battery. Okay, if you see the coil 1 which he connected to the battery and a key. Okay, fine. And another to a galvanometer. This coil 2 which is connected to galvanometer. What will he observe when? Number 1, key is inserted. Number 2, key is removed. It is quite simple. When key is inserted, okay, first of all, when key is not inserted, okay, we'll take the condition. When key is not inserted, that galvanometer will show 0, but that is not the question he asked. Now, when key is inserted, that galvanometer will deflect and comes to original position. Why? Because when key is inserted, current is induced. Current is basically magnetic field is produced. When current is passing through the solenoid, automatically magnetic field is produced. Because of the magnetic field, that magnetic field will show some impact on the coil 2. Because of the magnetic field B, current is induced in coil 2, which is nothing but induced current. And that induced current will be just for a second. That's it. Because of 1 second, one fraction of induced current, it will show deflection and comes to original position. And if it want to deflect, if it should stay there, what should happen? Already we have discussed, if you take coil and if you take magnet, either this coil should be in motion or this magnet should be in motion. Means there are conditions. Coil can be in motion, magnet may be at rest, we can find continuous deflection. Or if coil can be at rest, magnet should be in motion, then also you can observe the continuous deflection. Or coil can be in motion, magnet also can be in motion. If both are in motion, then also you can observe continuous deflection. But if coil is at rest, magnet is also at rest, then you cannot observe continuous deflection. Just it will deflect and comes to original position. So now this is the condition is there, na? They are not moving coil 1, they are not moving coil 2. So that when key is inserted, magnetic field is produced, magnetic field will show impact on coil 2, current is induced. That is also just in a fraction of a second it will be induced. Because of that induced current, it will deflect and comes to original position. That is the answer you have to write. When key is inserted, it will deflect. It will deflect and comes to original position. That is the point you have to add. Okay, when key is removed, what happens? Again, it will deflect, but it deflects in opposite direction. It deflects, again comes to original position. That is the answer you have to write. Okay, internal choice question they are asking. The magnetic field lines due to straight current carrying conductor are shown below. Fine. So there is conductor, it seems. Around that conductor, magnetic field is produced in circular shape. That is good. At which point the magnetic field will be stronger? Quite simple. We have discussed right hand thumb rule. Na? While coming to right hand thumb rule, when current is passed through the coil, magnetic field is produced, and that magnetic field will be in circular shape. And if you are moving away from the coil, that concentric circles, that radius and circumference is increasing, means simply to say magnetic field is decreasing. So if you are moving away, magnetic field decreases. And what they are asking, at which point the magnetic field will be stronger? At middle. Or you can add the point like near to the conductor. Point or the place which is near to the conductor, magnetic field will be stronger. If you are moving away from the conductor, magnetic field becomes weak. If you are moving towards the conductor, magnetic field will be strong. That is the answer you have to write. So at which point? Near the conductor. That you can add, that is more than enough. Next. Second one. Which rule is used to find the direction of magnetic field around straight current carrying conductor? You see, direction of magnetic field. Magnetic field is one factor, one property. And straight conductor, simply to say current is another property. When you have only current and magnetic field, use right hand thumb rule. Right hand thumb rule. Or you can write Maxwell's right hand thumb rule, Maxwell's corkscrew rule, whatever. If they are asking about current, magnetic field, as well as force or motion, then you have to mention Fleming's left hand rule. Fleming's left hand rule. So now answer is this, right hand thumb rule. That is the answer. Okay. Eleventh question, calculate resistivity of copper wire having length 5 meter, area of cross section 0.2 meter square and resistance 0.42 mu microamp. Fine. So what we have to find resistivity. So first of all, we know formula R is equal to rho L by A. We have to find rho value. Rho is equal to A is dividing, if it goes that side, it will multiply R into A upon L is multiplying, if it goes that side, it will divide. That is equal to R value. What is R value? They have given 0.42 microamp. So here already I gave one hint that whenever you find such type of things, capital M for mega. Mega means, okay, capital K is for kilo. Kilo in the sense 10 to the power of 3. Mega means 10 to the power of 6. Small m stands for milli. Milli is 10 to the power of minus 3. Mu stands for micro. Micro means 10 to the power of minus 6. N stands for nano. Nano means 10 to the power of minus 9. So these points you have to remember. So here they are asking about micro. Mu na, mu means it should be 0.42 into 10 to the power of minus 6 ohm. So R value is equal to 0.42 into 10 to the power of minus 6 ohm multiplied with A value. A value, area they have given 0.2 meter square. So 0.2 meter square, no need to change because SI unit of area is meter square only. Straight away you can write 0.2 upon L. L stands for length, and what they have given 5 meter. 5. So this can be written as 0.42 multiplied with 0.2 by 5 multiplied with 10 to the power of minus 6. So you have to solve this. 0.42 multiplied with 0.2. Okay, don't use calculators in your examination. They will not allow, but let us try to use calculator here and we'll see the solvation. Right, 0.42 multiplied with 0.2 is equal to 0.084. 0.084 by 5 divided by 5, which is equal to 0.016. So 0.0168 into, this is there not 10 to the power of minus 6. 10 to the power of minus 6. But in physics, we can never leave answers like a 0.0. Always it has to start with a number. So this point we have to move 2 times here. So when you are moving 2 times, this value should be reduced to 2 times. And reduced 2 times means don't write it as minus 4, because minus 6, if it is reducing, it becomes minus 8. Na? So answer should be 1.68 multiplied with 10 to the power of minus 8, reducing. Okay, this is the answer. Rho value is equal to 1.68 into 10 to the power of minus 8, and units ohm meter. This is the answer. Next, number 2, explain heating effects of current with the help of Ohm's law. Because whenever they are asking heating effects of heating effects of electric current, you have to go with the formula H is equal to I square RT. So how we are going to get that H is equal to I square RT? We'll see. So first of all, if you want to produce some heat energy in a device, definitely we have to give some power for certain time. Heat energy formula, we have heat is equal to power into time, right? Now H is equal to, we know power, P is equal to V into I. Substitute that, it becomes V into I into T. Now while coming to Ohm's law, V is equal to I into R. Substitute that V is equal to I into R, here it becomes H is equal to I into R and I into T. That equals to H is equal to I square RT, which is nothing but Joule's law of heating. Joule's law of heating, right? So explain heating effects of electric, you can write. So what is heating effects of electric current? So when resistance are connected across terminals and some voltage is given to that one, and some work is done because of the resistance, because of the voltage, resistance will, that all theory part, if you want, you can write within 2 to 3 lines. Because of the resistance, heat energy, it will be resisting the flow of charges, and heat energy is generated, and formula for the heat energy, this and all you can derive by using Ohm's law, because they have asked now, we have to derive Ohm's law. So that is the thing. Next, 12th question, when is a device said to be connected in parallel? When we can say connected in parallel? Whenever we find junctions or different answers you can write. Whenever similar terminals are connected to a single point, or similar terminals are connected to a junction, when multiple devices are connected across the junctions, across the points, and from the point where we can find 2 to 3 different terminals, all these points you can write. So that is a condition where we can tell it is connected in parallel. Okay, number 2, derive the expression for resistance of n resistors connected as shown below. Okay, what they have done, all 3 resistors they have connected in parallel, and we have to derive equivalent resistance formula. Okay, how to derive, we'll see. Just let me erase. Okay, when 3 resistors are connected, first of all we should have some idea about voltage division rule and current division rule. In parallel circuits, currents will change or it will vary, like I1, I2, I3, I4, etc. While coming to voltages, it will be constant because of junction, same potential difference will be applied. across this terminal as well as this terminal, so that voltages are constant. Now there are three resistors R1, R2, R3, names of that one, and capacities also. If you want, you can take it as R1, R2, R3 are the capacities. And total voltage from the battery is V, and until junction current will be I and voltage will be V. And while coming to the junction, to the R1, I1 current will pass, to R2, I2 current will pass, to R3, I3 current will pass. And near R1 voltage will be V, R2 voltage will be V, R3 voltage will be V. Now we know total current in the circuit is equal to sum of individual currents. Total current is I, which is equal to I1 plus I2 plus I3. And we know Ohm's law, V is equal to I into R. From this, I is equal to V upon R. Now we have to apply Ohm's law to all these three resistors. First of all, Ohm's law for the entire circuit, I is equal to V by R, which is equal to I1. So if you want to find I1 current, voltage at R1 is V by what is the R1 value? It is R1 plus current, I2 current, if you want to find, voltage at R2 is V by resistance of R2 is R2 plus voltage at third resistor is V, capacity of the resistor R3. Now from this, V by R is equal to, in all this, V by R1 plus V by R2, V by R3, V is constant. If you take V constant, 1 by R1 plus 1 by R2 plus 1 by R3. LHS, RHS, V will be cancelled. At last, we are going to get 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. But what they have asked, derive the expression for resistance of N resistors. N resistors we need. So plus and so on, plus 1 by Rn. This is the expression you have to represent. Okay, internal choice question. State Ohm's law and therefore explain resistance of a conductor. So what is Ohm's law? At constant physical conditions, temperature may be, pressure may be, or at a constant resistance. You see, for every device there will be resistance, and the resistance of the device is constant every time. At a constant resistance, voltage is directly proportional to current, right? And when at constant resistance, so V is equal to R into I, at last we can write V is equal to IR. And they are asking explain resistance of a conductor. What is resistance of a conductor? It is property of a material which opposes rate of current, which opposes flow of charges. Every conductor has some resistance, though it is pure conductor, though it is silver. Silver is best conductor of electricity. Though it is best conductor, it has some resistance. It will be opposing. 100% of current cannot be passed. At least minute resistance will be there. Minute value of resistance definitely will be there. So resistance is property of a conductor. Next, second one. Describe the effect of temperature on the resistance of metallic conductor. It's quite simple. When temperature increases, resistance also increases. Why? You see, this is conductor. There will be atoms. And if you pass free electron, because of high temperature, kinetic energy increases. Because of kinetic energy, more number of collisions. Because of more number of collisions, resistance automatically it will increase. Therefore, the resistance of conductor increases with increase in temperature. So when temperature is increased, resistance will increase. This is the only point. If you write, that is more than enough. And 13, every household produces a lot of material. Okay, fine. This is bio, leave it. So we have completed 2 marks and 3 marks questions. Moving to 4 mark. Okay, 15th question. Electric motor is a rotating device used for converting electrical energy into mechanical energy. That is the information. It is based on principle that when rectangular coil is placed in magnetic field and current is passed through it, two equal and opposite forces act on coil which rotates it continuously. Yeah, according to Fleming's left-hand rule, if there is a direction of current and there is a direction of magnetic field, I mean B, magnetic field, automatically force is generated when three fingers of left hand mutually, if it is stretched mutually perpendicular to each other, three fingers, forefinger will indicate magnetic field, middle finger indicate current, and thumb indicates direction of force produced in the current carrying conductor which is placed in magnetic field. Try to understand. There should be magnets and coil should be placed in between magnets. Okay, next, electric motor is used in electric fans, refrigerators, mixers, washing machine, computer, MP3 players, DVD. Okay, this is the information. And okay, diagram also given. You see, while drawing the diagram, of course, anyhow they have given there should be two magnets with N and S and a commutator segment. You see this rectangular rectangular coil, which is nothing but armature. Armature. Armature is the rectangular coil or rectangular loop or conducting rectangular loop which is placed in between magnetic field and which is connected to split rings, brushes, and connected to cell. Okay, and poles you have to mention for north and south, of course, if they ask you to draw diagram. And coil they have mentioned A, B, C, D. That is fine. Next, name the phenomena used in electric motor. So used in electric motor, what is the phenomena? See, directly you can write magnetic effects of electric current. That is the phenomena. Chapter name itself is phenomena. Magnetic effects of electric current is the phenomena used in electric motor. Or you can write Fleming's left hand rule also. That is also correct. That is also correct. Okay, number 2. Which rule is used to study direction of rotation of coil in the magnetic field? Fleming's left hand rule. Right. According to Fleming's left hand rule, which you see, which rule is used to study direction of rotation of coil? Direction of rotation means force produced. So when there is magnetic field and when there is current, when there is magnetic field, when there is current, when force is definitely force is produced, right? By using Fleming's left hand rule, we can find out. That is the answer you have to write. Number 3, what is armature? Which portion of the diagram above shows it? Armature is nothing but it is insulated copper wire wrapped on some rectangular frame of soft iron core. So this is soft iron core, or you can call it as insulated copper wire. Insulated copper wire wrapped on rectangular frame of iron core. This iron core, that coil can be wrapped like this. That copper you can wrap like a solenoid, because if after wrapping like a solenoid, when current is passed through the solenoid, magnetic field is produced, and magnetic here we have magnetic field, right? In between north and south we have magnetic field. Around this solenoid there is a magnetic field. When both magnetic fields are coming together, force is produced automatically. And what they are asking, which portion of diagram above shows it? Which portion? A, B, C, D. This is the portion in the diagram it is showing. That is the answer you have to write. That's it. You see how much easy. And internal choice, write the functions of, okay, function of horseshoe magnet. What is the function of horseshoe magnet? Which will produce uniform magnetic field. Use of magnetic field, you see there is north and south pole, it has to produce uniform magnetic field. When there is magnetic field, and again through this insulated copper wire, when magnetic field is produced, when both magnetic fields are coming together, force is produced, right? So what is the function of horseshoe magnet? Function of horseshoe magnet is to produce uniform magnetic field. Next, brushes connected to split ring. You see there will be split rings like this and brushes are connected, right? Now the function of brushes connected to the split ring here of motor is to provide current through the coil. Simple. So you see here, which is connected to power source, na? Positive and negative, and current will be passing like this. That current has to pass through the split rings, so that brushes are used. That is the only one thing which is used to produce current through coil. This is the point what they will see. Current to the coil. Like that you have to write the answer. So that is the end of sample paper 2 of physics and chemistry questions. And while coming to last sample paper, last question we have missed. This one. So state the factors on which strength of magnetic field due to current carrying loop depends. So here strength depends on length, strength depends on number of turns, and at last strength depends on magnet also. If magnet is so strong magnet, if it is strong magnet, field will be greater. I mean, production of current will be greater. Well, coming to internal choice, what happens to the electromagnet when connections through the battery is reversed? When connection is reversed, automatically magnetic field also will be reversed. That's it now. You see, we can see right hand thumb rule. If current is passing like this, consider magnetic field is in this direction. When current is passing in this direction, magnetic field will be in this direction. When current is changed like this, if you are catching, when current is passing in this direction, magnetic field will be like this, like this. If current is passing, magnetic field will be like this, right? That is the thing. So when connections through battery is reversed, What happens to electromagnet? Magnetic field also will be reversed. B, when the iron nail is removed from the setup, when the iron nail is removed from the setup, what happens? When the iron nail is removed from the setup, strength of electromagnet will decrease, because you see, this is the coil, na, where they have introduced iron nail like this, na, and when current is passed through it, magnetic field is produced, and in middle, how about the magnetic field? Magnetic field will be definitely uniform. In middle of the coil, magnetic field is uniform, so that only this iron nail behaves like magnet, so that only it can attract all the iron nails. If this is removed, strength of electromagnet will decrease, simple. And the extra magnetization due to iron nails vanishes when iron nail is removed. There is no magnetization for the iron nail. If iron nail is removed, it will not behave like a magnet. Only field will be present, that's it. So like that you have to write the answer. So you are done with sample paper 1 and sample paper 2, and in next lecture we are going to see sample paper 3. So that's it in this lecture.